And welcome back to Coast. George Norrie with your calls. Walter Cruttenden with us as we talk about this binary star system. Is it safe to say that's what it is, Walter, a binary star?
Yes, that's what you'd call it. I think they're pretty common out there nowadays. I believe the latest estimate is about 60% of all stars are in binary or trinary systems.
Is it its rotation that makes it what it is, a binary star?
It means it's gravitationally bound to another star. So, the closest stellar system to us we talked about is Alpha Centauri. So Alpha Centauri A, Alpha Centauri B, and Proxima Centauri are all gravitationally bound. So they kind of move around a common center of mass. And so likewise, we think that our sun is gravitationally bound to Barnard star, that it actually won't do a flyby as currently projected, that it won't reach an escape velocity, that it will actually go around a common center of mass with the sun.
Walter, what's your thought of the Big Bang? I can't put my finger around it. I just can't do it.
Yeah, George, that's a great question. I've read a few papers on it. Like everyone else, when I first heard about it, it sounded like an eloquent idea. It's actually a very ancient idea. The story of how everything was created was, the ancient stories, of course, would say God created or there was first light or something like that would seem to resemble a Big Bang. But the more I read about it, it's more like a big whimper. Are the latest theories that it's actually space expanding rather than because there's no space or time in which to have an explosion really, and as it expands, and we need inflation and stuff like this. But it sounds like a big miracle to me. I don't know, George. What are your thoughts?
It is perplexing to be sure, and I always have to bring God into the equation because science can't answer it for us, Walter. It just doesn't make a logical explanation of how something started from nothing. I don't get it.
I agree. Yeah, everything else we see in the world has a beginning. So, and it has a cause. So I won't disagree with you on that one.
Let's go to some calls. Let's go to Brian, truck driving in Indianapolis, east of the Rockies. Hey, Brian, go ahead.
How you doing, George?
Good, my friend. Thank you.
That's good. Yes, I got a question.
Okay.
Yes, do most stars like that have binary stars like that? And also another question also is, do you think there are two suns in our atmosphere?
What was that second part, Bri? You were breaking up a little bit.
Oh, okay. And also, do you think there are two suns in our atmosphere?
What do you think of that? Does every system have two suns, Walter? I don't think so.
No. So it's about 60% is the accepted figure out there, that 60% of all stars have some companion. But that was before they started discovering all these brown dwarfs, these very dim, difficult to see stars. And so I hear that some of the estimates are going up closer to 80%. And they might have, most of those would just have one partner and therefore be called a binary star system. But some of them have two or three or more partners. So it seems that, stars like companionship almost as much or more than people do.
That's a huge percent, 60 to 80%, isn't it?
Yes, it is. And, if you think back 200 years, the concept wasn't even known. So they looked in the sky, they thought, oh, those are just two stars that happen to be close to each other. It wasn't until we really had good instruments and could plot these things over a long period of time that we realized, oh, all these stars are in relationships. They're going around each other. And so when they realized it was the majority stars, that's when the sun started to look funny. Well, why doesn't the sun have a companion star? And that sort of set off a lot of conversation on that topic, which we think it does.
Let's go to Mark in Roseville, California. Hey, Mark, go ahead.
Hi, George and Walt. My question is why is there, for our Earth's magnetic field, we have a positive side and a negative side? What are their functions? You know, the sun did a 180-degree pole shift, right? And it turned our compasses on Earth 180 degrees. So I got a compass reading incorporating north is south, south is north, east is west, west is east.
What do you know about that, Walter?
Well, I do know, Mark, that you're right, that the Earth does have a magnetosphere, a big magnetic field around it, and it protects us from some bad elements from space. And so it's good. It's like a cocoon that we need, you know. Otherwise, the blast from the sun every day would cause problems. And if you do get a big, you know, X-class flare or something like that from the sun, it can fry our ionosphere, you know, cause problems with radio communications, things like that. And so it's good that we have a magnetosphere around the Earth. And, of course, yes, the Earth does have a north and south pole. And the geological record shows that it does flip now and then. But my understanding, it's more on the order of about every 700,000 years or so, the poles seem to flip. I'm not aware of any recent shifts, but there are certainly occasional, you know, sort of little loops that cause the compass to act weird or different, especially in certain places on Earth.
What's so amazing, Walter, is it all seems to fit like a puzzle, doesn't it?
Yes, yeah. And, you know, part of that puzzle, George, is I think the ancients actually knew a lot of this, and we're sort of rediscovering so much of it. And that makes it even more fascinating as far as I'm concerned.
Exactly. I mean, how did they know about it without technology? Unless they had technology.
Yeah. You know, there was a guy, professor at MIT, Giorgio De Santillana, and he and his co-worker, Hertha, wrote a book called Hamlet's Mill, where they tried to understand the origins of science and to figure out where mankind first started doing math and physics and things like this. And they thought they'd start by looking at the Polynesian culture, because they figured if anybody had some knowledge that we don't have today, it was these people that could somehow take a canoe, go over 3,000 to 4,000 miles of open ocean, navigate by the stars, and find a tiny speck of land. And so there is some lost technology there. You know, it might even be more psychic technology. I'm not saying it's some device or something they had. It could just be a knowledge. And when you read about these different ages that ancient culture talked about, they talked about, you know, an iron, bronze, silver, and golden age. And supposedly these silver and golden ages are an age of telepathy, you know, before even writing was required or needed.
You've done some work with Christopher Dunn, Robert Schock, experts on Egypt. Tell me about that.
Yes, Christopher Dunn will be one of our speakers this year in Palm Springs, October 20 to 22nd. And he is, you know, I like his discipline because he comes from an engineering background, and he's looking at different objects that came out of the Egyptian culture. And I think this year we'll be talking about how some of these vases were made and how perfect they are and how perfect some of the statues are. You know, just a casual glance doesn't. It looks beautiful, but it doesn't convey as much as instruments about how accurate and precise some of these structures are. And so they had some type of technology that was lost during the Dark Ages, you know, that we're just getting back in more recent times.
You think it was you think it was extraterrestrial technology?
You know, I'm a little bit skeptical. I think the universe is populated with lots of different intelligences, so I don't doubt that there's plenty of that. But if you look at some of the technologies that we had that were lost and that were then reinvented, like the geared device, the Antikythera device, completely lost geared devices for almost 2,000 years to the great clockmaking era again. The Babylon battery technology completely lost until Volta reinvents it in the year 1700. And other things like this. It's not aliens that are bringing it back in more recent time. It's humans that are somehow reaching a level of consciousness where we can figure these things out once again. And so I think it's mostly us.
On the wild card line, Diana's with us in Everett, Washington. Hi, Diana.
Hi. Hey, guys. Yeah, I'm really fascinated by this because I'm really interested in astronomy. I've never heard of this before. I'm just wondering if you're saying it's going to come around again in 11,000 years. Do we feel any effects of it before that time? And also, if there is any possibility that if it's going to be so close, we could actually travel there or to any planets? Are there planets around this star?
Hey, that's a great question. Because just a couple years ago, I think it was 4 or 5 years ago, actually, that astronomers were looking closely at Barnard star, and they think they may have detected a planet. So they're sort of debating that right now. I think a lot of people have said, no, that was just an aberration, but there's still a minority of people that say, yes, there is a planet around it. Because, as you know, they're finding a lot of exoplanets out there around other stars. So that would be really cool. And what was your other part of that question?
Can you travel to the star, but you can't get too close, right?
The common center mass, again, will only be 0.7 light years, so, less than a light year. But the star itself will probably close to 3-4 light years, something like that. You could, I understand that there's some games out there that use Barnard star and say that there's a planet that's inhabited in it. So I'm not that much into video games, but apparently some people have already thought of this.
Let's go to Mike in Montana. Welcome to the show. Hey, Michael.
Hello. So my question is, I've been studying a model of the solar system, and you may know about it, called the Tychos. And it hypothesizes that Mars is the binary twin of the sun, and they're in a 2-to-1 relationship. And it hypothesizes a bunch of other stuff, but I'm wondering if you've heard of this theory and or a model, and what you think of it.
I have heard of it, and I don't think too much of it, quite frankly, Mike in Montana. I look at anything. I like to keep an open mind, but, Tycho Brahe was sort of the last holdout on the heliocentric system, which, by the way, the Greeks knew about 2,000 years before Copernicus brought it back.
And Tycho Brahe was an astronomer, wasn't he?
Yeah, very famous astronomer, and actually he did some meticulous readings of the stars, where he kept very accurate records on their positions and the planets especially, and that helped Kepler, who came and lived with him for a little while, at least in the same town. And of course, Kepler is the one that really helped us understand that orbits are not circular; they're elliptical. And since then, that led to understanding the laws of gravity. It helped Newton. It's probably the biggest breakthrough in astronomy in the last 500 years, Kepler's laws.
Is it safe to say that the binary star is a twin of our star?
No, it's much smaller. It's there's various classes of stars. The sun's a pretty typical star. There's many stars that are much bigger than the sun, and there's a lot of stars that are much smaller than the sun, including red dwarfs and brown dwarfs. So this red dwarf, our Barnard star, is about 15% of the Earth's mass, which is equivalent, as mentioned, to about 48,000 Earth masses. And it's also very dim because, it's a red dwarf, not a blazing sun like we have. And therefore, if Earth was around it, it wouldn't give up much more light than, a few dozen moons, something like that.
Older, younger, same age?
It's supposed to be much older. The guess is about 10 billion years.
Wow.
And so that's,
more than double.
So people are wondering, then how did it come into a relationship? Was it just passing by and we captured it? No one really knows.
What's the life of a sun, Walter?
Oh, I think, our sun, the life is something like, I think it's supposedly been around about 4.5, 5 billion years so far, and people believe it might have that much longer still to go, so maybe 10 billion years or so. But some very some red dwarfs and brown dwarfs might be longer than that, much longer, and then some very super hot stars would burn out much quicker in just a few billion years or less.
When they burn out, do they all become black holes?
No, the best theory now is, it has to be a certain amount of mass before it can become a black hole. And I forget the exact number, but I think it's roughly 3 solar masses would have enough mass there that when it collapsed, it would become a black hole.
Are there still new stars being formed in the universe?
They believe so, yeah. And some of these nebulae out there, they call them, star nurseries.
Like the Horsehead Nebula?
Yes, yeah, exactly. There's so much hot gas swirling around, they think that that's the way that stars might be born.
That is pretty dramatic. Walter, where do people get your books?
Through Amazon. Lost Star, Myth and Time is my first book there. There's a good one out on Audible. We had somebody do it with an English accent, and so I added an extra chapter in there. That's a good way to do it. But they'll also we'll have them at our conference. If people are interested in the Conference on Precession Ancient Knowledge coming up, it's just cpaconline.com. That's cpakonline.com. And I will have, the 15 speakers I mentioned, researchers all talking about this over 2.5, 3 days, and roughly 300-400 people in the audience collaborating with us. So it's really a fun time.
Okay, we're going to come back and take final calls with you in a moment on Coast to Coast AM. And welcome back to Coast, our final segment with Walter Cruttenden as we talk about this binary star system. Truly remarkable, Walter. And you know what? You know you're right, don't you?
I sure do. And I don't mean to be egotistical or conceited or anything about it. It's just there's no other way to explain why the sun is curving through space. It's just basic physics. It takes a large mass for that to happen. So we're looking for what that mass is, and we think it's Barnard's.
Is it important that it had this binary star? Does that star enhance our sun at all?
There must be some reason that so many stars form companion relationships, gravitational relationships. And I don't think we have a clue why that is right now. The ancients talk about their higher ages. We're still in a very low age right now. As advanced as our technologies are, I think it's still a pretty simple time as far as answering questions about the universe.
Walter, why isn't NASA jumping on this or some other major organization involved with science?
It moves very methodically. They need to be careful. When they're flying rocket ships to the moon or Mars or something, everything's got to work. So also, it's nobody's job out there. I did talk to some astronomers and physicists out there about this basic theory, and because I've been noticing that all they do is patch up the old theory. Nobody's asking, hey, maybe very little of the sun's motion is due to axial wobble. And when I asked around, I basically found out that it's nobody's job to think of new theories. It's kind of done by, people outside of the industry that ask profound questions. You see that happen in archaeology right now, too. The archaeologists are very careful about interpreting digs, going slowly, not wanting to ruin any artifacts, trying to fit them in place. But they fit them into place in a preconceived notion, Darwinian notion, that anything before us must be more primitive. And you have people outside the field like Graham and Chris Dunn and other speakers we have asking these questions. Well, maybe it isn't so linear. Maybe there's things that happen along the way. Maybe there are cycles. And so I love this type of questioning because it leads to new theories.
Let's go to Joseph in Anaheim, California. Hey, Joseph, thanks for holding.
Hey, George. Hi, Walter. I do have a question. If the great year really exists, what are the higher ages like? You mentioned that many cultures talk of this golden age. What can we expect on our future civilization here?
What does the future hold for us, Walter?
I love this question. So we know what the past holds for us. We go back to the Dark Ages, things were pretty bleak. And we have some myth and folklore about a higher age. Hesiod, the Greek historian, talked about it being a beautiful time when man lives in tune with nature. Nature gives of itself freely. People live to be ripe old ages. And you find all these scriptures from different countries, the Egyptian king list, the Chinese dynastic records, the Persian records. Even the Bible talks about people in these higher ages living to be very long ages. Seth, Methuselah, Noah, et cetera, like this. And then as you get down into the Dark Ages, people barely live to be 40 years old, And, of course, we've been coming out of that. The lifespan has roughly doubled since the depths of the Dark Ages. But if we're to believe, some of the myth and folklore about a higher age, things are going to get much more beautiful. And I think it's a bumpy road to get there because, we have expanding minds and we develop technology, and sometimes we don't use the technology right. Like AI is something you wonder how much we'll use it properly versus improperly. But my hope is that, that we do get back to a time like the Greek mythologies talk about, when man lives in tune with nature once again, and he's fully developed his capacities, like a yogi or a Zen master, things like that. And you don't need as much outward brute technology because we tune into the trees and the rocks and the landscape, and we just know how to live more naturally. I think there's a lot more happiness in the future. So it's hard to describe in much more detail than that, but I would encourage people to read, Hamlet's Mill, for example, this book by Giorgio de Santillana out of MIT. It's just beautiful, and it hints at how beautiful the higher ages might be.
We take text and tweets. What do we have for Walter, Tom?
Hey, Walter, Jane in Montana wants to know if all planets are affected equally by the sun, or is there one that might be affected more negatively?
That's interesting. Gravitationally, the lighter planets are affected more, and that's why these small dwarf planets, Pluto-sized planets or smaller, really have these elongated orbits and are much more affected versus the biggest massive planet like Jupiter, hardly as much tilt at all, or Saturn would be less affected. Great thought.
Let's go to first-time caller Judy in Indiana.
Hi.
Hey, Judy.
I've been a coast-to-coast listener since 1993.
Well, thank you for staying with us so long.
And being a first-time caller. No, there's a man named Charles Hall, and he wrote a book called the Millennial Hospitality Series. He said that he was a weather specialist in Dreamland from 1965 to 1967. And we hosted a group of aliens then, and they were from a planet. He couldn't remember the name of the planet, but it was by, their star was Barnard Star. And I was just wondering, you said that they believe that there is and he said that Barnard Star was a dwarf star. And there's a planet, you think, by Barnard Star?
Yes, so Barnard is a red dwarf, about 15% of the sun's mass, but it's still big. It's still a very big, hot star. And some speculate that there is a planet around it. And there's been so much speculation, it's made it into video games and things like this. So it's it wouldn't be impossible. They're finding more and more exoplanets, planets around other stars all the time. I went to the Keck telescope once with Jeff Marcy and his team. Jeff used to be head of astronomy at Berkeley, and he was the first at finding a lot of these exoplanets out there. And the technology's really gotten good. So it looks like, there's probably, if there's, a couple trillion stars out there, you multiply that by 2 or 3 or 5 or something like that to imagine how many planets there are. And excuse me, I said 2 trillion stars. I meant 2 trillion galaxies, and each of those has a couple of 100 billion stars. So I don't even know what the number is for the number of planets, but it's big.
It's a big old universe, isn't it?
It's amazing. It sure is, George. And I love the fact that you are not afraid to explore a lot of these questions with your guests and listeners. We need a show like yours.
I want answers. And, Walter, you do a great job. You've been with us a long time, my friend. Let's go west of the Rockies. Heather's with us in Honolulu in Hawaii. Hi, Heather.
Hello. Hi. Aloha.
You too.
Hi, Walter. I teach physics out here at Pearl Harbor, and I teach astronomy for the University of Houston remotely, and I'm very interested, and I'm glad to be pointed at your website tonight because it looks so interesting to me. I want to read up on all the things that you have posted there. But I'm curious if the binary star with this system is considered on the main sequence. Is it burning hydrogen? What's the status of its evolution?
Yes, I believe it is. Let's see. We're an M class. That's correct. And what is Barnard's? I should know that off the top of my head. Obviously, it's a much smaller star than ours. It's a red dwarf, and nowhere near as hot. I believe the surface temperature is something like 3,000 degrees.
Okay.
I think that would still burn hydrogen, right?
Yeah. I mean, the surface temperature of the sun's about 6,000. It takes about 10,000. If you're talking Kelvin, 6,000 to 10,000 degrees. Surface temperatures is what you see from the main sequence, typical of our sun. But is this Barnard Star, or is it another star that is in this binary system?
We believe it is Barnard Star, which is, is the fourth nearest star, the second closest stellar system to us.
Yes, it is.
And, and all the literature shows that it's coming closer to us, coming, pretty much straight at the sun right now. And, of course, everyone believes, it's just going to pass us by. but I don't think it is. I think it's the reason it's
No,
accelerated
there's
in the first place.
catastrophic events and timelines in geology that are showing catastrophism over gradualism in geology records, as well as records indicating cosmic perturbations of some object. And it just really puzzles me that there were papers on this in the late 80s regarding a mysterious object in our solar system, and then they vanished.
Yes. Well, if you're teaching physics, have people really look into the wobble theory of precession. It's very well accepted, of course, and precession is a real phenomena, but it's the amount of precession.
Right.
Yeah, and I think it's only a few arc seconds, and therefore the sun that's moving across the sky at 50 arc seconds, that leaves a lot of room for motion, and you have to explain that some motion some way. So I hope you look into that.
Thanks, Heather. Appreciate what you do out there. It's exciting. Science is exciting, Walter, isn't it?
I love it. Yeah, I couldn't get enough of it when I was a kid, and so I'm glad I still get to do it as an adult.
What's your target on Lost Star, the film?
The film, we have a couple of co-producers that will be at the conference with us. And my partner, Philly Berto, is working on a lot of the special effects now. We have a script we absolutely love, so we can hardly wait to get into principal photography.
If you had to guess when it would be out, what would that be?
I'm hoping it's next year.
Super. Any more books coming?
You're always working on some. So if my last main book was Lost Star, I've just completed a paper called Lost Star Found, and it's on our website at the binaryresearchinstitute.org website. And so, yeah, a few people have asked us to expand that into a book, and so that's one of the projects on the works.
Walter, thanks again for being on the program. Keep in touch with us, my friend.
Thanks, George. Appreciate what you do.
You take care. Walter Cruttenden. Up next, we are going to be talking about dreams and the paranormal on Coast to Coast. Have you had a strange dream? You need a little help with it? Well, we'll be able to do that, too, when we come back.